Out of an old book from the 1960s, an experimenter's book, I thought this would be an interesting device to build, a passive booster for broadcast band DXing. So basically what it is a 365 picofarad variable capacitor and a 7-inch long, it's a 7.5 inch long farad antenna core. Well, I've got a variable capacitor and also a long already wound ferrite core from an old radio here. It's from a transistor radio that wasn't repairable. So here's the variable capacitor, and here is the, oh, it's only 6 inches long, but that should work fine. It's matched to this capacitor. And these boosters are quite interesting. You put it next to a transistor radio or any radio that has an antenna of any kind, any AM radio, and it will boost the signal by a lot. You tune this into the same frequency and you put this in the right direction and you go quite an increase. I've used them. So I thought this would be an interesting project to build anyway. So I'm just going to remove this, gently remove the coils. Coincidentally, one thing that is interesting about this coil, it's from a radio that was built around 1960, an English radio, and I believe here it's got a provision to attach an outside antenna. So I think that goes up through here, and I think that might be that extra coil there, just to couple the outside antenna into this loop stick. So I'm going to remove this and this and decide what box I'm going to put them in. Here I like to make note that there's holders here, and they're connected to the circuit board by little rivets. There's 2 holders here, and I'd like to save these and use them again. So I'm going to drill out these little rivets right there. I'm going to drill out right here and here. So I'm going to drill these out and save the holders. Okay, so now I'm going to drill them out. Not tight enough. Yeah, maybe that's through. Okay, it's through. And this one. Okay, now these 2 over here. Totally wrecked something there. Smell of burning phenolic board. Everything there seems to be okay, so now I just have to unsolder all the wires for the loop stick antenna. Okay, so here I've got some soldering iron, and I gently remove this wire here. there. Now I'm going to remove, let's see here, there's some wires here. There, I think these out there. There's some wires from here. Come through there. And then those wires look like they wind around that thing there. I don't know what that is. To pull that thing out. Like some kind of a coil in itself, so I'm gonna have to figure that one out so I don't break it. There's another wire up here I don't want to break. Okay, so this thing, can't figure it out here. It seemed to want, and there it's pulling out. And over here, well, that should probably just pull out with a little bit of force from my fingers there. Not coming out, so I'll have to look at another way. The wire loops around there, so it is tied in there. Yeah. Oh, it was held in by those little ties. Okay, so that's out. Now I'm going to take out the variable capacitor. Well, I see that extra little coil must be a loading coil for an external antenna, and I guess this extra wire here goes to come off. That one goes to the circuit board, so this must be a loading coil. Here, I'll just take this off here and unsolder this one here, which is here. So now that's off. So I'm just measuring the meshed and unmeshed capacitances of the this variable capacitor. Now, both are lower than the 365 picofarad, which was pretty well the standard for medium wave radios in North America and Japan. So what we have here is the lowest one is 25, and both of them are 25 when they're open, and when they're fully closed, just take that there. Okay, so we'll close that completely. And one is 219 picofarads. And the other one is 194. So I guess they had, since it's an English radio, they had they wanted to tune in long waves, so they used a lower, or that wouldn't make much sense. You'd think they'd use a higher. But anyway, maybe this, they just found it was more useful, since they could wind coils that would resonate with us more readily in the medium wave band and the long wave band. Who knows? That's what the engineers decided, and this radio looks like it was a quality radio in its time, but Unfortunately, it was just too far gone to be able to be restored. The cabinet was just completely in bits and pieces. So there was quite a bit of stuff that I could salvage from it, and one of them was the transistors. It had some interesting Mullard 1950s Mullard transistors. So here I've got the variable capacitor and the loop stick connected together, and I'm just going to show how the incredible increase in volume it will give you when you tune it into the same. You can just barely hear this little transistor radio here. Now listen how it increases. Right here. Oh, there's tuned off. It depends on which radio, the orientation. You have to play around with it, but for most radios with the loop stick aerial, it works fantastic. And so I'm going to put this in a little box, and I found that it worked best, covers most of the broadcast band. I've wired these two, you got two capacitors in here, and I wired the common. They come together, these two coils come together, so I wired that to the common, and the IF capacitor goes to this coil, and the other one goes to this coil, or I mean goes to this capacitor. So it seems to have the best coverage when I connect those two like that. So I'm going to try another radio and see how that works. Okay, here's a big old Zenith transistor, Zenith 200, which was one of the ones I got working in an earlier video. I got tuned to a very weak station. Can't even hear it.
Take advantage of the opportunity to get started today. Call 1-800-353-6081. That's 1-800-353-6081. Again, 1-800-353-6081.
Comes in like gangbusters. So this is a very useful device for AM DXing. So there's just one more thing I'm going to fool around with and see if I can find out. This, as I said earlier, I think this coil here is for coupling to the outside. So I'm going to do some experiments with that to see, because I would like to use this, put this in a little box with two alligator terminals on it, so I could hook this up to an old radio, and so I could use this as its antenna. I think that will be a very interesting thing to do. So I decided to go this route here. Join the two coils together and put the variable capacitor across there, because I was getting good peaking, but I wasn't getting good coverage across the whole medium wave band. And now by doing it this way, I'm getting good coverage across the medium wave band. Here, here is the radio tuned to around 570 AM. Absolutely no, you can't hear a radio station there. Tune it in. Tune in a station.
Sites look legit, but they're far from it, and the borrower needs to be careful and make sure they're dealing with a lender that's licensed and just be careful, do your research, and we're here to help. That was Chuck.
That's how much it increases.
Free loans to new customers with no fee to apply and a...
Okay, here's a radio station at the other end of the band. It's about, I think this is around 1400. So here you can barely hear it.
Not realize. Most people, according to these studies,
Here's KFBK in Sacramento. It's about 1,000 miles away. You can barely hear it there. And I bring it up.
Now, I get it if you can't write it, maybe. I still don't get that. But I understand we use keyboards all the time. Or our phone, we just tap things now. But to not be able to read cursive?
So it increases the signal strength, I would say at least, but I can't measure it without some kind of a meter or something, but I would say it increases it by 10-20 times anyways, so it does both ends of the medium wave band now. So now I'm just going to start experimenting with taking a signal off it by wires. So I'm going to demonstrate how the voltage changes as I tune through the band. I'm measuring with a voltmeter from here to here across the parallel tuned circuit. And as I change the frequency, I tune into local radio stations, and the ferrite rod picks them up and induces a small electric current, which causes circulating currents, and if I measure the voltage across here, it'll increase when I tune into a station. So here's an AC voltmeter. It measures high frequencies. It'll measure high frequency voltages. You can see it moving back and forth just with the electric fields that are flowing through the ferrite rod. There, I just touch it and the voltage goes up. So anyway, I'll show how, zoom in on the face of this. There. Just look here at the face of the meter here. So here, I'll go from one end of the band to the other, and I'll just go next lowest setting. So here, as I go through, I go to, shows the radio stations, local radio stations. There's another one. There's another one. And there's a really strong one. And go back here, go to the next highest scale. Here's a strong radio station. And another strong one. So I can't even see those little ones. unless I go to a much lower scale. There. So anyway, that just shows how this passive circuit, this tuned circuit here, receives a radio signal, and this coil with this capacitor will create a voltage across it when you tune into a station, and then that voltage can be tapped off and detected and amplified, and that's how an AM radio works. So anyway, the next thing I'm going to do is see how much signal I can get off the coil. This little coil here, I'm going to remove the small coil, but I'm going to utilize the coil that's already on there and see how much signal I can get off there. And if possible, I'll use that as an input to radios that don't have loopstick antennas, so then it'll give old radios that don't have internal antennas a lot of sensitivity, and you don't have to use a wire antenna. The coil that was on there was useless, and so I wound my own coil on there. Here it is, and it seems to work quite well. I put about 1, 2, 3, 4, 5, 6, 7, 8 turns, 8 or 9 turns on there, and I've put the voltmeter across it, and it seems to be working quite well. I've got it on the lowest scale, the 0.001 volts, and I'm tuning across the medium wave band. We'll start at the lowest frequency, 550. The tiny little radio station there, very weak, you can see. And there's a strong one that's 600. There is 690. Now that'll be 650. There is 690. There's 73. There's 98. It's 1130. 1320. 1470. That's all the main radio stations here in my area. So this is very sensitive, this tuned circuit. So I'm going to put it in a box. I'm going to put it in this box here, and this loop stick aerial is too long for the box, so I'm going to have to drill a hole in the side, and part of it will be sticking out. It's no big deal. So that's what we're going to do. I'm going to remove these standoffs here. They're just getting in the way. And I'll just glue this with hot melt glue onto the bottom here, as I will put this inside there, and I'll attach it also with hot melt glue. If you ever want to take them out and reuse them for some project, they can just pull right out, and the hot melt glue comes off very easy. Just going to cut these off because they serve no useful purpose. So I'll see if I can fit this in okay. The best way to put this in. Better put that down like that. And put it in the middle. This has to be like that. Okay, I better do it from the front. Just see what level I have to put it up to. I'd like to put this in the middle if I can. I just like things to be symmetrical. And maybe I should stick this end out. Still isn't big enough. I'm going to have to maybe move this further over here so that this part can stick out. I'll have to stick out about an inch. So I'm going to have to work that one out. So we'll see what I'm going to do some measurements here. slowly. There we are. That's a very dull drill bit. Now get all this stuff out of the way. Take an X-Acto knife and ream it. It's a lot of gunk. I was drilling slowly. I didn't get a chance to get hot, which would probably have given it a better cut if it had got hotter for plastic. But, I think that should be okay. So now I've drilled the holes and they're mounted. All I have to do is put the hot melt glue in. Actually, I'll solder them first, and I have to solder this back to connect it to the capacitor, but I'll put the hot melt glue in and have the capacitor in place before I do any soldering. But it seems to sit in there quite nicely. Now what I'm going to do is take these two wires out here. I've moved the coil here so it fits in there quite nicely. And I'll take these, the coil that I made, and I'll take the two wires and I will attach them to two alligator posts. These ones here. Ones like this. I'll put those in the back wall connected by wires so that this can be taken off and attached to a radio with an external antenna jack. So here I've got a hot melt gun. I'll put a blob right here, right there for the variable capacitor, one there, and one here where it will, much bigger one here where it's going to sit. Do that like that. Fiddle around with it to get it in the right position. And it has to sit flat. Then I'll put a little bit more down there so it will hold it in place. I think that should be okay. I want it to be sitting above the bottom and flat against the front. So hopefully, maybe I'll put that on its side like that for the time being. Okay, so here I'm going to attach or hold in place with hot melt glue the antenna. There we are. Is that a rundown? And now here. And that should hold in place. So now I'm going to put the dial back on. The dial won't thread on because there isn't enough room this way, so I'm going to have to get another dial and see. Maybe one with from a transistor radio would be better. This one fits on really nice and it goes smoothly, so I'll keep this one. Put that other one out of the way, use it for another project. So we got the old transistor radio again, tuned to a station around 1400. Working quite nicely. Here we are.
Syracuse 41-13. They returned 3 interceptions for scores, but they picked off Kyle McCord 5 times at all. And Old Dominion, they routed Georgia Southern
Moves it quite nicely.
47-19.
So here I'm going to drill 2 holes at the top here, so I can mount the 2 outside banana jack holders. Now first one. Better tighten it with the tab off to the side in there so I can solder it. Grab it and give it a good tightening with there. Oh, still not tight enough. Getting that tab tightened is a bit of the pliers in there. Now, that should be okay. Now put the other one in. Put that variable capacitor in so I don't damage it when I'm putting these in. Okay, that's got, oh, I see, that one the tab should be in between the 2. Oh well, I'll just remove it. So how we now have attached the coil to 2 outside banana jacks so that wires can be wrapped around them or banana jacks can be put into these, or alligator clips. So I'm just going to close this off now. Wrong size. Should have used a driver for this. So there's the finished box. So I know it works, so I'm going to try it now on an old radio and see how it works with this connected by alligator clips to the radio terminals. So in summary, going over this article here, all these parts, if you don't have a radio like I had, a little transistor radio to remove the parts from, all these parts can still be obtained. On eBay you can purchase these ferrite rods. I'd get one as close to 7.5 inches as possible, and it calls for cotton covered wire number 24. The best wire to use is called Litz wire, and Litz wire is it can have it's stranded wire, and it's insulated usually with polyester or something like that, and it's designed for coils, and it will give you the best performance. So you can order Litz wire on eBay too. It's pretty reasonable. It's called LITZ wire, Litz wire, and this is a ferrite core. And you can also order, you can purchase these variable capacitors. They still make them. So you can buy everything for this radio on eBay. So all you need is a box. And in this book it says to make a wooden box, but I just decided to use that plastic box, and it works fine, so I'm happy with that. So good luck with if you decide to build your own version of this. I was very happy with the performance. Here's just something I thought was rather interesting. This here is, I put the scope on and tuned in the station, and this is a radio station. This is 1470, a local station, and here's another one. Some of them are very strong. That one's not quite as strong. I think that one, there's a strong one too. That one was the sharpest one. Just auto set it again so it locks onto that particular signal. Considering it's a completely passive circuit, that's quite interesting how it does that. And it's developing a signal of about 200 millivolts peak to peak. There we are. A really strong one. Put it in the right direction and I think it's extremely strong. Right there. A nice 200 millivolt signal, peak to peak. Anyway, I just thought that was kind of interesting.